All right, welcome back to the deep dive. Today, we're tackling a topic that I think is on a lot of people's minds these days, and that is building for a greener tomorrow.
Yeah.
It seems like every day there's a new headline about climate change and what we need to do. And I'm really fascinated by the role that architecture can play. I mean, buildings, right, they use a ton of energy, a ton of resources, and I think it's really encouraging to see how architects are starting to address these challenges head on in their designs. What do you think?
Absolutely. I think it's a really exciting time to be in this field. For a long time, sustainability was kind of seen as this niche thing,
Right.
maybe even a bit of a luxury.
Yeah.
But now it's really becoming mainstream and it's being integrated into all aspects of design, from the very first sketches to the choice of materials.
And it's not just about making a building green.
Right.
It's about making it better in every way for the
Right.
people who use it, for the community, for the planet.
Totally. It's
Mhm.
really about creating spaces that are healthy, comfortable, and inspiring.
Yeah. And I think, for listeners who are maybe not super familiar with this topic or maybe they feel a little bit overwhelmed by it, I think that's totally understandable. There's a lot of jargon, there's a lot of complex ideas. But I think the goal today is to really break it down,
Yeah.
to give you a solid understanding of the core principles of green building design, and, to do it in a way that's actually, fun and engaging.
For sure. For sure. And to look at some real world examples of how this is actually happening.
Exactly. So let's start with the basics. I think a good place to begin is with the fundamental ideas that are guiding architects in this greener approach. What would you say are the absolute kind of non-negotiable principles?
Well, there are really five key principles that I think kind of underpin all of this. The first one, and it's probably the most obvious, is energy efficiency. The goal here is to dramatically reduce how much energy a building needs, and especially its reliance on fossil fuels. So architects are using some really clever strategies to do this, like orienting the building to maximize natural heating and cooling.
Oh, yeah, that's so important.
It is. And then using super efficient insulation. You can almost think of it like a thermos for your building.
Right. Keeps everything at the right temperature.
Exactly. And then, of course, incorporating renewable energy sources like solar panels. And what's interesting is that the cost of solar has dropped dramatically in the last decade.
That's true.
So it's becoming a much more viable option for a lot more people.
Makes sense. So energy efficiency is kind of like the low-hanging fruit. What's the next big idea?
The next one is water conservation. And this is about way more than just fixing leaks or having low-flow toilets. It's about minimizing water use in every aspect of the building and even the surrounding landscape. So things like rainwater harvesting systems,
Okay.
drought-resistant landscaping, using gray water for irrigation. It's really about thinking holistically about how water is used and trying to make the most of every drop.
So it's not just about using less water, it's about using it more intelligently.
Exactly. Then we have material responsibility, and this is a big one. It's about moving beyond just thinking about the initial cost of materials and really considering their impact on the environment and on human health.
Right, right. Because some materials are just, inherently more problematic than others, right?
Absolutely. So architects are really prioritizing materials that have recycled content, that are sourced locally.
Hmm.
So you're reducing transportation emissions, and that are free of harmful chemicals like volatile organic compounds or VOCs, which can off-gas and affect indoor air quality.
Yeah, I've heard about that. That's a big concern, especially with newer buildings.
It is. And then we come to indoor environmental quality, or IEQ. And this is all about creating spaces that are healthy and comfortable for the people who use them.
Yeah, it's about making sure the building is actually good for you, not bad for you.
Right. And this encompasses a lot of different things, like making sure there's good ventilation so the air is fresh,
Oh, okay.
maximizing natural light, because it's not just about energy savings. It also just makes people feel better,
It does. It really does.
maintaining a comfortable temperature,
Mhm.
and even managing noise levels.
Yeah.
It can get quite noisy in a lot of modern buildings.
Yeah, you don't want to have to shout to be heard.
Exactly.
Yeah.
And then finally, there's site sensitivity. And this is all about designing buildings that are in harmony with their surroundings.
Okay.
So instead of just clearing a site and starting from scratch, architects are really taking into account things like the existing topography, the native vegetation, the local ecosystem.
Mm-hmm.
And they're trying to design in a way that minimizes disruption to those things and even enhances them.
That's really interesting. So it's not just about the building itself, it's about how the building fits into the bigger picture.
Exactly. And all of these principles are interconnected.
Yeah.
They all influence each other.
Right.
So a truly sustainable design is one that considers all of these things together in a really holistic way.
All right, so we've got these core principles. Now, how do these ideas actually translate into, real world design choices? What are some of the techniques that architects are using to put these principles into practice?
Yeah, so there are a ton of different techniques, and I think a good way to categorize them is to think about passive design versus active systems.
Okay, I like that. Passive versus active. Tell me about passive design first. What does that mean?
So passive design is all about taking advantage of the natural environment to reduce energy consumption and improve comfort. It's about working smarter, not harder.
Give me some examples.
Sure. So classic example is orientation. By carefully positioning a building on its site, you can maximize the amount of natural light that enters the building during the day.
Mm.
And that reduces the need for artificial lighting, which saves energy and creates a much more pleasant environment.
Right, right. And you can also use orientation to take advantage of natural ventilation.
Exactly. If you position the building correctly and you design the windows and the openings in a strategic way, you can create these natural air currents that cool the building without having to rely so much on air conditioning.
I've been in some buildings where they do that really well, and it's amazing how effective it can be.
It is. Another great example of passive design is using thermal mass.
Thermal mass. Okay. Explain that one to me.
So certain materials, like concrete or brick or even water,
Mhm.
have a high thermal mass, which basically means they can absorb and store a lot of heat
Okay.
and then release it slowly over time. So you can use this to your advantage.
Mm.
For example, if you have a concrete floor that gets a lot of sun during the day, it will absorb that heat and then release it slowly at night, helping to keep the space warm.
It's like a natural heating system.
It is. It's kind of like a giant battery for heat.
Mm-hmm.
And then another passive technique is shading.
Shading. Okay.
Using overhangs, louvers, even vegetation to block direct sunlight during the hottest parts of the day. This helps to keep the building cool and reduces the need for air conditioning. It's simple, but it's really effective.
Okay, so those are all passive strategies. What about active systems? What's the difference there?
So active systems are the things that actually use energy to heat, cool, and ventilate a building, like your HVAC system, your lighting, your appliances.
Okay.
But the key in sustainable design is to make sure that these systems are as efficient as possible.
Right, because if you're going to use energy, you want to make sure you're using it wisely.
Exactly. So there are a few main strategies here. The first one is HVAC optimization. This involves using high-efficiency equipment and then carefully designing the system so that it only heats or cools the spaces that need it when they need it.
Okay, so it's about making the system work smarter.
Exactly. Another key strategy is integrating solar energy. And this can take different forms, like installing photovoltaic panels on the roof to generate electricity,
Okay.
or using solar thermal collectors to heat water. And in some cases, architects are even integrating solar panels into the building facade.
Wow, so the building itself can become a source of clean energy.
It can. And then finally, there's smart building controls. These are systems that use sensors and software to monitor things like temperature, occupancy, and lighting levels, and they automatically adjust the building systems to optimize energy use. So for example, if a room is empty, the lights will turn off automatically.
Makes sense. It's like having a brain for your building.
It is.
Yeah,
And these systems are getting more and more sophisticated all the time.
that's really cool. So we've talked about passive design, active systems. What about materials? We touched on this a little bit earlier, but I know it's a huge topic.
It is, and it's one that's getting a lot of attention these days. I think architects are really starting to understand that the choices they make about materials have a huge impact on the sustainability of a building.
Well, and the health of the people who use it, right?
Exactly. So there are a few key principles here. One is doing a life cycle analysis of materials.
Life cycle analysis. Okay, what's that all about?
So basically, it means looking at the environmental impact of a material throughout its entire life, from the moment it's extracted from the earth all the way to the end of its useful life.
Okay.
So you're considering things like the energy used to produce it, the transportation emissions, the waste generated during manufacturing, and what happens to it at the end of its life. Can it be recycled? Can it be reused?
So it's really a much broader perspective than just, what does the material look like or how much does it cost?
It is,
Yeah.
and it can be pretty eye-opening.
I bet.
Another important principle is sourcing materials locally. And this has a lot of benefits. It reduces transportation emissions, of course, but it also supports local economies, and it can often lead to using materials that are more appropriate for the local climate and the vernacular architecture.
Right.
It just makes sense.
Yeah.
And then there's a big push towards using materials that are renewable and biodegradable,
Or
things like bamboo, wood, even certain types of plastics that are made from plant-based materials.
so materials that come from nature and can return to nature.
Exactly. And then finally, there's a growing emphasis on designing for deconstruction and reuse.
That's an interesting one. Explain that to me.
So traditionally, buildings have been designed to last for, 50, 100 years or more. And then at the end of their life, they're basically just demolished and all the materials end up in a landfill.
Right.
But now architects are starting to think about how buildings can be designed so that they can be easily disassembled at the end of their life.
Okay.
And the components can be reused or recycled. So it's kind of like taking a Lego set apart.
That's a really cool idea. So it's almost like the building has a second life built into it.
It does. It's really about creating a more circular economy for building materials.
So this all sounds great, but how do you actually measure sustainability in a building? I mean, you hear a lot about LED certification. What exactly is that?
Yeah, LED is a good example of a certification system that's used to evaluate the sustainability of buildings. LE stands for Leadership in Energy and Environmental Design. And it's a point peak system that looks at all different aspects of a building's design, construction, and operation.
Okay.
So things like energy efficiency, water use, materials, indoor air quality, and site sustainability. And the more points a building earns, the higher its LE rating.
So it's kind of like a report card for a building's sustainability?
Exactly. And LEED has become the most widely used green building certification system in the world. And there are different levels of certification, like certified, silver, gold, and platinum.
Okay.
And a lot of developers and building owners are really eager to get LEED certification for their projects.
So it's good for business as well as for the environment.
It is. It shows that you're committed to sustainability.
Are there other certification systems out there besides LE?
There are. There are several other ones that are gaining traction. One is called WELL, and it focuses specifically on the health and well-being of building occupants. And then there's BREEAM, which is a UK-based system, but it's used internationally. And there's the Living Building Challenge, which is even more rigorous than LEED.
Wow. So there are a lot of options.
There are, and I think that's a good thing, because it means that there's a lot of innovation happening in this field, and that there are a lot of different ways to approach sustainability.
Right. It's not a one-size-fits-all kind of thing.
It's not. It really depends on the specific project and the goals of the client.
Okay, so we've talked about the principles, the techniques, the certification systems, but how does this all actually play out in practice? How does an architect actually go about designing a sustainable building?
Well, it starts with a really deep understanding of the site and the context. What are the climate conditions? What are the existing natural features? What are the needs of the users? And then it's about integrating those things into the design from the very beginning. It's not about just adding on a few green features at the end. It's about making sustainability an integral part of the entire design process.
So it's a mindset, not just a checklist.
Exactly. And technology plays a huge role here. Architects are using all kinds of amazing tools to model energy use, day lighting, water consumption, and all sorts of other things.
That's really interesting.
It is. And these tools are getting more and more sophisticated all the time. They allow us to test different design options and really fine-tune the performance of a building before it's even built.
So you can kind of run simulations and see what works best.
Exactly. And then, of course, there's the construction phase. And here, it's really important to have a good team in place, people who are committed to sustainability and who understand the best practices for green building.
Yeah. You can have the best design in the world, but if it's not built properly, it's not going to perform the way it should.
Exactly. And then even after the building is completed, the process doesn't end there. There's ongoing monitoring and evaluation to make sure that the building is performing the way it was designed to. And there's also a lot of education that needs to happen with the occupants of the building.
Oh, yeah, so they understand how to use the building in a way that maximizes its efficiency.
Exactly. So it's really a holistic and ongoing process.
Yeah.
And it's one that I think is incredibly important.
I think so, too. To wrap things up, could you share a few examples of buildings that are really pushing the boundaries of sustainable design, buildings that are kind of, leading the way?
Sure. One that always comes to mind is the Bullitt Center in Seattle. It's a 6-story office building that was designed to be the greenest commercial building in the world.
Wow.
and it really lives up to that billing. It's completely self-sufficient in terms of energy and water. It has solar panels on the roof, rainwater harvesting systems, composting toilets, and it's built with all non-toxic materials.
That's incredible. It sounds like a building from the future.
It kind of is. Another really interesting project is the Bosco Verticale, or Vertical Forest, in Milan. These are two residential towers that are covered in trees and plants.
I've seen pictures of that. It's amazing.
It is. It's a great example of biophilic design,
Yeah.
which is all about bringing nature into the built environment. And the benefits are huge. The
Mm.
plants help to clean the air, they reduce noise pollution, and they create a really beautiful and calming environment for the residents.
Yeah, that's one of those projects that really captures people's imagination. It shows what's possible.
It does. And then another project that I really admire is the Panjidin International School in Thailand. This is a school that's built entirely out of bamboo.
Wow, bamboo.
Yeah, that's an incredibly sustainable material. It grows quickly, it's strong, and it's very versatile. And the school is a beautiful example of how natural materials can be used to create a modern and inspiring space.
I love that. It shows that sustainable design doesn't have to be high tech.
It doesn't. Sometimes the simplest solutions are the best.
Well, this has been an incredible conversation. Thank you so much for sharing your expertise with us.
My pleasure. It's a topic I'm really passionate about.
I can tell. And I think it's so important for people to understand this stuff because the choices we make about the buildings we live and work in have a huge impact on the planet.
You do?
And I think it's really empowering to know that we can make a difference.
Absolutely.
So if you enjoyed this deep dive into the world of sustainable architecture, be sure to subscribe to the Deep Dive for more in-depth explorations of the forces shaping our world. We'll be back soon with another fascinating topic.